My name is Ihor Dvoretskyi. I am the operations engineer in the Mirantis company. That's the #1 pure play OpenStack company in the world. So our company provides the largest services related to the OpenStack between the world companies that are working only on the OpenStack. And today we'll speak about the following. So I'll tell you what is OpenStack, for what purposes you may use it, and why should you use it. Afterwards, I'll tell you a few words about a really great new component of OpenStack. It's named Murano. That's a tool that allows you to convert your OpenStack cloud into a fully loaded PaaS solution and use your own applications in it. After that, we'll speak about the containers and the container integration into OpenStack. And the final step will be discussing the integration of Kubernetes into OpenStack. And after all, I'll show you a little demo. How does it work? So, what is OpenStack? Why should you use it? OpenStack is totally free and open source cloud computing platform. Regarding to the latest polls that has been performed in the, in the last year, OpenStack is most important and the most popular open source solution for building clouds, and it's most popular open source solution overall. Because the number 2 is KVM hypervisor and number 3 is Docker. So OpenStack is more popular than these two solutions. OpenStack is not a single tool. There's a set of different tools that might be combined in a whole complex into your own cloud. That brings you a lot of benefits because you may combine these components into Z combinations that you would like to have. You may use Z components that you would like to use, and you don't need to use Z solutions that you don't need. OpenStack has the not so long story, but the current year it takes 6 years. Its age is approximately 6 years. It has begun as a closed source project of NASA and of the Rackspace hosting. NASA provided a compute cloud that has been called as Nebula. Rackspace provided the storage solution. And in 2009, these tools has been combined into a whole solution, has been open sourced, and that solution has been called as OpenStack. OpenStack releases every 6 months. So every 6 months you receive a new version, a new release of the cloud, and this solution really fastly growing. So every 6 months you receive a lot of new possibilities, a lot of new tools for simplifying managing your cloud. One of the tools that has been arrived into the core repositories of the OpenStack in the past years is Murano, that has been originally developed by Mirantis company, and at the current moment is part of the vanilla OpenStack. So Mirantis is a component that allows you to install applications on your cloud simply in 2 or 3 clicks. So Murano is an application catalog like the Google Play Market, for example, where the different applications are located, and you may use any of them, and in a few, or in a half an hour, in a few clicks, you will install them on your cloud and extend it. This catalog is located at the website apps.openstack.org. So there are a lot of different applications, and Maybe every half a year, there are more and more of them. Murano works as a proxy, as a divider between the underlying infrastructure level, so the OpenStack itself, and a buffer of the Murano locates applications are located. Also, Murano supports different OS options, so you may use either Linux-based applications or Windows-based. But by the fact, the current moment, only Linux-based applications are released in the catalog, but Windows as a host machine for loading these applications also available, Windows images. So what are containers and what the benefits we receive using the containers? So container is a technology that allows you to isolate your existing environment from your existing application from the whole environment. So maybe the most popular, the current moment project related to their containers is Docker. There are a lot of some different projects, but we'll speak today about Docker. So container management is totally different from the classic management of the applications, because you have a strong container that is combined from several components that allow you to build only your application with that components that you need to have, without any extra components that are not necessary for you. And containers, due to its model and due to their concept, allow you to receive the huge performance. Containers provide you a huge flexibility, isolation, and portability, because you may easily migrate containers from one host system to another, from one cloud system to another. So that are the greatest benefits of using containers. There are a lot of people who think that containers are the same as virtual machines. So that's not correct, because there are a lot of differences between classic containers and the classic virtual machines. So at first, containers are primarily built for using applications. At the same time, virtual machines are based for virtualizing the whole operating system. So there is a layer, there is a different abstraction layer between the containers and virtual machines. So containers might be easily managed as a solid atomary unit, and you may easily use it as a single application. At the same time, to manage virtual machine, you have to use the whole hypervisor with a lot of different configuration tools to manage your networks, to manage your volumes, to manage your storage, to manage the operation system itself. At the same time, Docker, at the current moment, for global and production usage, supports only Linux distributives. At the same time, you may use for the full virtualization any operating system. For example, you may install Windows on the KVM hypervisor, and you'll receive the whole Windows system. There is a great difference in the concept of security and isolation between containers and virtual machines, because container technology uses a shared kernel and the shared resources between the different containers. Different containers are located on the same host machine. That is not totally secure, because sometimes any exploit may allow any user of one container or any process in one container to damage any process in another container or in on the host machine. The classic virtual machines are totally isolated, totally secured. So when you're running a virtual machine on the KVM, you have no possibility to access your host machine in any way. You simply have to run their libread, for example, management scripts, and you'll manage your hypervisor, but not directly from the VM. The greatest benefit of containers, one of the greatest benefits of containers, is their performance. Because when you use the fully virtualized system, you receive approximately 10 or 15% of the overhead comparing to the classic bare metal system. When you use container, you have no overhead because containers, on the point of view of the operation system, containers are simple applications, so you use them as the single application, and there are a couple of resources that are allocated only for the processes that are being run in that containers. Another great benefit of container as a solution for managing applications that is the fact that you may manage containers as an application. So you may write some code, and this code will manage your containers. Because when you'd like to manage the virtual machine, you'll have to use the more. You may use either manual way for full configuration of the virtual machine, or you have to use another much more solid and strong configuration tools like Puppet, Chef, and something similar. For containers, you may use the native Docker API to manage them easily. It's a great solution. But also containers also have the couple of third-party services that that provide for you possibility to manage them much more easily than simple usage of API. One of them is Kubernetes. So the Kubernetes, yesterday there was a great talk by Mandy White about the Kubernetes. That was originally the Google only developed cloud container system. It has been originally named as a Borg, and a few years ago it has been open sourced, and there were a lot of companies who also committed a lot of tools into the Kubernetes repository. So at the current moment, it's not a Google-only technology. That's really fully shared and open source technology. Kubernetes itself is a container orchestration tool that runs Docker. First of all, there are possibilities to run another types of containers like Rocket, but the main type of containers that are managed by Kubernetes are Dockers. And at the same time, Kubernetes might be run on the various environments. So you may run the Kubernetes cluster on your own laptop, on the bare metal, or in any kind of cloud. Kubernetes consists of the different components. They are the following. So the main atomary unit of Kubernetes is pod. So that's a group of applications that run the same context. For example, if you'd like to build a group of containers that serve for you as a backend, you have to build several containers with you have to build one image, but you'll run the couple of containers that will run the same information. There will be clones of each other, and the group of these containers will be named as a pod. Another important unit of Kubernetes is controller. That's a unit that allows you to provide for your cluster the same state as you have expected. So you may easily describe in the configuration of your Kubernetes cluster that state that you'd like to receive. For example, you'd like to have 5 nodes of Nginx. And at the current moment, you have a cluster with 10 bare metal nodes where the Kubernetes cluster is being run. So At the moment when one of the nodes where one of that containers runs prints down, in a few minutes, the controller will bring up one more container on another node to provide the same state as you expected in your configuration files. Another unit, another component of Kubernetes is a service. So that's a group, that's a logical group of pods that run together and provide the same role. For example, you may have a couple of load balancers that are running on the different pods that are managed on the different nodes, but they have their own, their similar structure, and they provide the similar concept of their purpose. So this set of pods is named as a service. And you may also allocate some different objects in the Kubernetes clusters using labels. So if you'd like to run the different applications that might be used either on development, or on staging, on production environment, and you have the different policy of scaling, the different content of that containers, you may label them, and you may label them, and the different actions will be performed on that containers. And of course, the main component of Kubernetes cluster are the Docker containers itself. So this is a little example of the whole Kubernetes cluster that runs Murano, that runs the Kubernetes cluster with a Kubernetes pod where it's been run the Nginx web server. And this whole structure is being built on the base of Murano above the OpenStack. So I will tell you about this later. So now we'll bring you a demo. Okay. So to start building the whole environment on the OpenStack, we need the OpenStack itself. So here's a pre-built OpenStack using the DevStack tool. It's running locally on the remote server. And at the current moment, we have no instances, have no allocated scenes there. And we need to run our application. So there are a couple of pre-installed applications that I have imported there earlier, but I'd like to show you how to import some packages in here. So here's the app catalog that I've described for you earlier, and you may search there anything. For example, we'd like to use the Nginx container. So you may simply click on the package name, copy it, and paste here, and it will be installed. But it won't install because we have it already. So to deploy the whole environment, we'll have to name it. We'll have to provide one of the networks. So at the current moment, there are no allocated networks. And we'll have to bring some components. So we would like to build the Nginx-based cluster. So we'll simply push the icon of the Nginx 0. We may either choose the Docker standalone host, and this application will simply run as a simple Docker container. And at the same time, we may build the whole cluster. So that's why we need to allocate it to some pod. We may name it like a web server. We'll have to also configure the Kubernetes cluster. So there are a couple of configurations needed. So we'll have to configure the current number of minions that being used there. Also, we may extend the maximum number of minions. Minions are the virtual machines that are allocated to the nodes of Kubernetes, and using the minions, you may deploy your own applications on the different nodes. So in the current status of this cluster, we'll run 2 replicas of this application, and if we'll have necessity, the number of minions will be extended to 3. Also, we may provide the whole number of the gateway nodes that are being used as a load balancer for the whole Kubernetes cluster while you're trying to reach it outside. So in this configuration, the gateway nodes have been pre-built with HA proxy. And these gateway nodes also may receive the floating IP that is globally reached. And you may simply, using that floating IPs, reach your own Kubernetes cluster. So we'll also configure it now. So we may use also the key pair, but I haven't allocated it. We also need to finish the configuration of the Kubernetes pod. We'll choose their container host well, where this whole application will run, and we may create the application. So, at the current moment, this environment is ready to deploy. Deploy will take approximately 30 minutes. That's why I prepared the pre-built environment for the last part of the demo. So here we see the pre-installed cluster where we have the 3 Kubernetes nodes where the Docker containers have been run. And we have also one gateway node within which you may access your environment. So clicking on the gateway node IP address and coming to, you may see there our pre-built Nginx application. Another benefit of Kubernetes is that you may simply scale your Docker containers, and if some of them will be killed, you may reach it in a few seconds. So. So, at the current moment, there's Nginx applications being run. We may kill it. and running Docker PS, we'll see that the previous container has been built approximately 12 hours ago. That was the last rebuild of this cluster. But the final version of this container of Nginx has been launched 6 seconds ago. So Kubernetes has automatically relaunched that container using the prebuilt image, because we have described that behavior in its configuration. So the conclusion of Docker with the Kubernetes is a strong and solid complex that allows you to avoid some issues while you try to deploy your applications on the basis of your own cloud. So from the side of the Docker, we have described the benefits of Docker usage. There are a lot of benefits, and using it, you'll receive all of them. So you'll receive the portability, you'll receive the flexibility, you'll receive the performance of your application, and you'll receive some kind of isolation in comparing to the other applications that are also run in their containers. Kubernetes itself provides you the whole complex of managing these Docker containers, and Kubernetes allows you to dynamically scale your environment. If today your application is being run on 5 nodes and tomorrow you'll have to launch this application on 500 nodes, in a few clicks you may perform that behavior. So right now, in a few clicks, you may run your cluster on 500 nodes, for example. At the same time, you may run your containers totally isolated from the underlying system. So it doesn't matter what provider of the hardware of the cloud do you use. So Kubernetes run either on the OpenStack, it also may run on the public cloud providers like the Google virtual machines. You may run Kubernetes on your bare metal, on the laptops, for example, using some automated tools like Vagrant, for example, and so on. So you may develop your applications anywhere, and you may launch them in that environment that you'd like to have. To launch applications, Docker-based applications using Kubernetes on the OpenStack, you may use Mirantis. That's the best option for performing that, because Mirantis allows you to avoid a huge amount of unnecessary actions, like manual configuration of your Kubernetes cluster, the whole manual configuration, I mean. You don't need to check their whole hardware possibilities to launch or not to launch these containers, because Kubernetes will analyze their current cluster situation, current cloud situation, and will provide you the best option to launch your containers. And of course, Mirantis has its own app catalog, so you shouldn't build manually your own images, your own applications, if you have to use the simple vanilla images, for example. You may simply use the global application catalog and use this application. And of course, OpenStack provides the whole infrastructure service for your own cloud. So if you have your own hardware, you may use the OpenStack for launching your cloud on that hardware. That will be fully isolated. The data on that cloud will be only yours. You shouldn't share that with anyone. And that are the greatest benefits of using the private clouds. And of course, the OpenStack is the best solution for creating the public clouds. So that's all. I'm ready for your questions.
Hi, I have a question about related to Kubernetes. So there is such tool, Apache Mesos. It's very popular because it fits very well for running Hadoop, Kafka, and Spark and other tools, because it can represent your resources as one computing unit. So my question is, can Kubernetes be used for managing your Mesos infrastructure? And the second one, if no, how Kubernetes fits for those tasks as representing all your resources and as one computing unit? Or is there such possibility to organize your infrastructure to be similar to what Mesos do? Thank you.
So first of all, Kubernetes is a system that allows you to manage your Docker containers, a container orchestration system. I had no experience working with Mesos on the OpenStack because, first of all, I'm an OpenStack developer. I'm not the developer of the Kubernetes, but I'm strongly working with their community and the Kubernetes itself. At the current moment, Kubernetes is being used as the best solution to launch their containers on their OpenStack basis, because you have possibility to launch it easily, as I showed you before. If you'd like to launch some, for example, Hadoop clusters, you may use differently another tools. For example, there is an OpenStack Sahara project that allows you to run your Hadoop cluster on your OpenStack-based environment. But at the current moment, I can describe you the easiest way to launch Mesos on the OpenStack. Okay, thank you.